participated in software development in the DEX software, which was and still is a famous expert system software in this region and wider. Besides doing research, he also teaches, as I said, at University of Nova Gorica, School of Engineering and Management, and also at Josef Stefan International Postgraduate School. He was a member of the organizing committee of several conferences, such as Intelligent Systems Conference, Conference 100 Years of Alan Turing and 20 Years of Slice, Conference of the International Federation of Operational Research Societies, and International Symposium on Operations Research in Slovenia. Marko will give us his talk on qualitative multi-criteria modeling method DEX, approach, recent advances and applications. Marko.
Thank you very much for this very nice introduction. Also many thanks to you personally and to the organizing committee for inviting me and giving me an opportunity to talk mainly about my and our own work at the Josef Stefan Institute. And as Mariana already said, we are the biggest national research institute, and these days we mostly live off working projects, European projects and other types of projects. And in this talk I would like to present two things. One is the approach, one of the approaches that we use in our projects, which is also the core of our research and development, which is the method DEX, and also about some results in different projects here under the title of applications. So basically the whole talk is organized around the method DEX, from the approach, implementation, some history, applications, and some findings. And I hope I will be able to make some take-home messages about these lessons learned. But because this is a plenary talk, let me first put everything in the context, even though I believe that it is not really important given a very strong multi-criteria decision analysis sections in this conference. But anyway, just first a few words about multi-criteria decision analysis, multi-criteria decision aiding. MCDA is the acronym that is used for both of them. And we also often use the acronyms MCDM, which M stands for making or modeling. I tend to use MCDM in this way, modeling, developing models. So basically the approach, which I believe is quite familiar to all of you, is that a typical multi-criteria decision analysis use case is when we deal with a number of alternatives. This can be just two alternatives, or it can be hundreds of alternatives, depending on the situation. And we wish to do several things, like select the most important one, the best one, rank alternatives, and so on. This is on the next slide. And the approach is multi-criteria. That means that we try to define criteria, find out criteria, and describe these criteria in terms of some variables, criteria that describe these alternatives. In the next stage, we try to aggregate in some way these criteria. Models can be of different types, as you know. It can be hierarchically, as shown here. They can also be implicit, one-level model, or implicit models, and so on. But overall aim of the process is, first, to evaluate alternative, to give some values, some evaluations of these alternatives. This is one important task. And the other very important task is what I call analysis here, is to look at the problem and see the sensitivity of, let's say, changing some data about alternatives, the sensitivity of criteria used in the process, how these small changes or larger changes affect the analysis, the results of evaluation. So both evaluation and analysis are very important in this task. Probably many of you are familiar with the term that was coined by Professor Bohanec, which is usually called problematics, decision-making problematics. So when we have alternatives, there are several tasks that we usually want to achieve. One is to choose the best alternative, for example, this one. Another is to sort or classify alternatives into some set of distinctive classes, like here. There are 3 classes illustrated. And another problematic or task is to rank alternatives from the best one to the worst one, and of course this ranking can be, in some cases, only partial. Another important point in this area is to say that usually all this is done in collaboration with different kind of people. They can be only one present, usually a decision maker, but also some other people. Usually this is done in collaboration with decision owners or decision makers, the people who are responsible for the decision, who want to decide. And this is quite often aided by other people, like experts who know something about the area of interest, and often it is also connected with decision analysts. People, and I often play the role of a decision analyst in project, who typically help to organize the whole process, to suggest methods, to use methods, and to help in that the project or the evaluation goes from the beginning to the end. Also, I took a look, this is 3 days ago, I looked at the Wikipedia about MCDA methods, and it's quite a, let's say, organized mess, I would say. So you can see a long list of different methods, and this is probably one of the problems a novice is faced when coming to this area. There is a number of different methods, there is a number of different acronyms, and I believe some acronyms are very well known to you, like AHP, ANP. Today I listened to some presentation about Promethe here, MOT, multi-attribute utility theory, and several others, while some methods are clearly unknown. So usually we need some kind of a classification. And this is my attempt to classify, to make some distinctive characteristics of methods, MCDA methods, based on different other sources, of course. It's not just idea. So usually we discriminate methods according to the task, the problematic, which I've already explained, like choosing, sorting, ranking. Then there are several approaches. Probably the most well-known approaches are what is called usually American school, which is basically developing the whole model explicitly so that it is represented in some formal form. Then the other approach is outranking, or French school, which is typically based on comparison, pairwise comparison of alternatives, for example. And there are some other approaches here. Also, in connection with DEX, it is important to distinguish between quantitative and qualitative methods, because DEX, the method is qualitative, as I will show later. And sometimes we also distinguish method by acquisition of preferences. And this here I put in this slide just few examples of well-known methods, just to give you a clue of where they are positioned. For example, the few full aggregation American school, we can see the method AHP, Kepler-Trago, MOT, Macbeth, and also I put DEX everywhere. Quantitative, qualitative, and so on. And here is just to put our work, the method DEX, into context. So this will be an introduction already to DEX. DEX is typically used for sorting and classification. It's a full aggregation system. The model is developed explicitly and fully. It also contains some elements of rule preference, rules and so on. In this it is comparable, somehow comparable with dominance-based rough set analysis, which is quite well-known approach. It is qualitative and it is direct. The knowledge, the preferences are acquired in a direct way. So this is now time, there is now time to move to the DEX methods, to the core of my presentation. So first, few information, what is DEX? What is the approach? What is the idea behind? And I can say that it is quite an old idea. Actually, it originates in, let's say, 1980s. And it was a kind of a combination. It began not as part of operational research, which was at that time quite, I would say, not very friendly to methods originating in other fields, like artificial intelligence, like qualitative methods, and so on. Basically, DEX was coined as an attempt to combine multi-criteria decision analysis as a core, but also to introduce some elements that were relevant, particularly at that time, like expert system modeling, defining experts' knowledge in terms of rules, Machine learning was also very new at that time, and also the idea was to incorporate fuzzy reasoning in decision support model. So this was the core idea, and basically if we trace back the development of the method, this is probably the first paper which didn't use the name DEX at that time, but it was a predecessor of everything that followed, and the authors were Janet Evstatiou for Darm University at that time, and Vladislav Rajkovic, who became my, let's say, teacher and colleague later on when he returned from the UK to Slovenia, to Yugoslavia at that time. I can just say that this paper had quite several ingredients of the later DEX, like decision tables, like here. It was heavily influenced by fuzzy methodology, which was introduced in our method at the beginning, but later on somehow dropped for several reasons. And this is the next paper, which is from 1988, and I would say this paper already has all the elements, all the ingredients of the methods, like aggregation functions determined, let's say, in a point-by-point fashion. I will explain this later. Rules, decision tables, and a hierarchical structure of criteria. So let's say in 1988, the method already got its main shape. It was being developed later on in many different aspects, but this is somehow the core, or let's say one of the first papers on that. So what is DEX? Essentially, it's a very simple method in essence. So to describe its characteristic or its static properties is, in fact, it's a multi-attribute modeling method. So it employs a hierarchy of attributes like many other methods. Those of you who work with AHP are very familiar with such hierarchies. So if you want to evaluate car, I used this toy example from the literature mainly, you have to consider sub-criteria like price and technical characteristics, and then you decompose the decision problem further. This is very, very common for multi-criteria and multi-attribute modeling. And once you have such a model, then you define a decision alternative like some car, and the car is evaluated from bottom to the top, obtaining some evaluation at the top. If there are several alternatives, of course, you can repeat this in this way. So it's a very traditional, very typical approach. However, what is different? It is qualitative. What does it mean? That instead of attributes or criteria or variables, whatever we call them, which are typically numerical in most of the methods, in DEX, we model this, or we define scales which are qualitative. See, so we don't speak about price in euros or kunas or whatever, but we describe this in terms of qualitative values like bad, acceptable, good, excellent, and so on. And this is the idea that was brought in from expert system modeling and, let's say, machine learning, which was very much at that time under the influence of using symbolic qualitative values. And of course, there are some other methods, qualitative in multi-criteria area, like Zapros, maybe you know, or VDA, verbal decision analysis. And there are some mixed methods like Macbeth, which use symbols, but then they transform them into numbers. DEX typically doesn't transform these values into numbers. And the second important thing is that usually, usually it's very useful if these values are ordered from bad to good, so that attributes are turned into criteria. And the second most distinctive property of DEX is that instead of some formulas, usually many methods rely, for example, on weights, and they assign some weights. Buying price is maybe 60% and maintenance price is 40%. No, in DEX we describe this relationship, this aggregation of attributes into high-level attributes in terms of decision tables. So each decision table contains some combinations of values of lower-level attributes, and this is the assignment to the high-level attribute. And these tables are designed typically by decision makers and or experts, or in collaboration of both when defining multi-attribute models. I should also stress that each row in such a table actually represents some very elementary decision rule, like if fuel is medium and safety is good and comfort is medium, then the decision maker considers technical characteristics very good. So this is the main essential ingredients of the method. However, the next part of the talk I would like to devote to some aspects which I call dynamic aspects, and for which I feel that it is in OR literature particularly, it is not, let's say, absent, but it's probably too overlooked. Many methods are defined in terms of the components of formulas that are used to define a model, but much rarer, in rare cases, we speak about how to use these models. And there are two aspects of using such models. First of all, we have to create such a model. And at the end, once the model has been developed, we have to use it for some particular practical purpose. And in using and developing of this method, it was always very important for us who work with this method is to ask these types of questions. How should we proceed that we obtain a model from the head of a decision maker, of an expert? How can we verify it for like completeness and consistency? How to deal with uncertainty, which you cannot avoid in decision making? How to ensure, this is very important, transparency through comprehensibility. So how that once you have a model developed, how can you display it to other people, to other participants in the decision-making process? Support model dynamics, this is almost neglected in the literature. And it is the question, you have developed a model, but it is not perfect. You would like to change it. How to do that? How can you support that? These transformations of the model. Now, this is very rarely addressed with most other methods. And the usage part is, of course, how can we obtain data alternative? This is a common question. But of course, how to deal with incomplete data, very important. Can we and how can we explain and justify results, validate results, what kind of analysis can we perform, and assess the quality of decisions. So this was, as a message, I think one of the important messages of my presentation is that whoever develops or uses an MCDA method should ask these kind of questions also, in addition to this methodological, how the model is represented, and try to find ways of answering these questions. And in order to make this model practical, also used in practice, we developed quite some pieces of software. Currently, let's say the main software that we use is called DEX. It's a program which facilitates these things, and I will go through this shortly in some brief steps. What can be done here? But I will also try to answer also these questions which I asked before. So how to obtain the model? And here at the first stage, what we do is we obtain the structure of attributes, the attributes that influence the decision. Here I have to admit that probably our approach is let's say, the weakest in offering the support that it offers to decision makers, because this is still more art than science. Basically, what we can really do here is based on, so try to find out, to define all the attributes or criteria that are relevant for the decision, try to structure them in a tree, but this is mainly handcrafting manual work. Here I can add that in the past we have also developed some methods, some approaches to learn the structure of the models from data. They work to some extent, but they were, let's say, I would say, maybe this is another topic, but they were a little bit too complicated and required too much data to work with, so they are not really used right now very much. However, when we turn to decision rules, so in decision rules, the task is to define decision tables from the knowledge of decision makers and experts. Here I can claim that the software and the method we have developed offer a very good support to decision makers. And here, maybe is that our goal when trying to define this kind of decision tables is to support the decision maker in many different ways, like And we offer, or the software actually can act using different strategies, like letting the decision maker to fill in the answers which are needed here, or the system can employ some additional information about scale orders to fill in the table. If we look here at the detail, it actually says that only 8 rules of 12 are defined, but the function is determined 94%, which means that there is some algorithm behind which is based on dominance, which fills in some missing answers here in the table. So the whole process is much more effective. Still, we usually do this interactively. And when talking about projects, we typically sit together. Me as a decision analyst, the decision maker, 2 or 3 people, we sit behind the computer and define these rules. And it's an iterative process, which is not probably too difficult, especially if tables are small, but it requires some engagement of all of us. And the important point here is that once the tables have been developed, they are validated for consistency and completeness, which I believe is a very important property of final models. Also, a lot of effort is put here to try to transform this original representation of the decision table into other representations, like more compact rules, graphical representation. Also, as I will tell you, we are able to infer some weights from the table by this method, which is shown here. So in doing this, we try to bridge the gap between the qualitative tables and some weights which are very common in multi-criteria decision analysis. So in fact, without telling about the method, particular method, it is possible to infer weights from the table. And here is the principle. It's putting a hyperplane in the space of decision points, which were defined by the decision maker. So from here we can get weights. And vice versa. It also works the opposite way, that the decision maker specifies some weights, and then the system tries to interpolate the points in the decision table. It's a very effective, but not always proper or correct way of doing things, but it is possible. Changing model structure. I told you this is very important, and it is encountered in practice. So, and it's important then to have software which allows you, for example, like here, it quite often occurs that we find out that some value here in the table is missing. We want to extend the scale of attributes. We want to extend the scale of output attributes, or to delete something. And the principle we are using here is, whenever such an operation is required, let us try. The software behind tries to retain as much information as was given previously, so that the changes are minimal and the changes required on behalf of the decision maker are minimal. And also, I'm looking at time. Also, it's very important that the system is able to perform even if some input data about alternatives is missing. And I can just say, yes, it is also possible with DEX. And the principle which is used here is what we call interval or set evaluation. And there's some analysis. Okay, I think it's more important that we also go to the applications, to the usage of this method. So first about history. As I told you, the method has quite a long history. What is important on this slide is that it was so far supported by 3 generations of software. Here are the names of the software. Currently we have DEX, and from the length of these arrows you can conclude that there's also quite a time to get something new, probably, and I agree with that. Then the next important message is that the method grew very slowly. In the first period we mainly had some let's say initial first applications. Then in the next decade it was used very much in the national, in Slovenian applications, very well known the housing fund applications and for our Ministry of Science and Technology. But nowadays it's quite international and used in international projects. I compiled last year a database of all DEX models that were developed in the history and the models which are available to me. So they were developed by either myself, my students, my co-workers, my other colleagues. And this is a timeline of those models. In fact, it turned out that in all those years, we collected almost 600 models for different tasks. Here is approximately the, let's say, time shape of the number of models and the category of models. And you can see they can turn into a research, class, educational, meaning that they were developed for education or by students, some demonstrational models, and commercial. So these were, let's say, something usually required by industry and some kind of commercial industrial applications. So just to give you an idea, I made a lot of statistics of this. It's quite interesting. I decided to show you just for the idea what is the average size of our models. It's about slightly less than 30 attributes. But you can see the size has a very, very, very long tail, and in the database there are also models which contain about 300 attributes, which I consider really very, very large models. And I can tell you these are used models used in agriculture. I tried to compile some kind of areas of decision problems addressed by all these DEX models. And this is probably the best I could make from the whole collection. You can see there are basically very many decision problems addressed by models in this database, starting with, let's say, models for evaluating computer technology, which is normal. Me and my colleagues have a background in computer science, but then you can find a lot of other areas like projects, defining or evaluating organizations, evaluating schools, quality of schools, in management, in production, and so on. I can't go in more detail about that. I can only tell that about 1/2 of these models are published in publicly available publications. So I can help you finding publications if you're interested. And for those which are not published, I can give you more information what I know about them. Now,